Okay, I think we are ready to start the afternoon session of the second day. Yeah, we're trying out something new. We'll see how it works, and you tell us later on. We thought it would make sense to organize this panel session, and I think in my mind, the main purpose of this panel session is that I think all the work which is happening here is in support of us. Yeah, so we need these methods. Yeah, we need more accurate methods. We need faster methods, and so we are your customer in that sense. And so perhaps talking a little bit about how let's say, what we learned over the last days. Yeah, what we liked, or where we still see some challenges. I think that might help. And I picked a few topics like talking a bit about the relevance of this noise factor thing, which specifically is visible to us in our day-to-day business, and perhaps talking a bit about how the OEMs look at the future of the AI technology, what are their expectations, and where are perhaps the constraints they see, the opportunities, and perhaps GPUs and fast computing is obviously a big theme, so perhaps we can talk also a little bit about this. So that's something we try to do over the next, let's see, half an hour, 45 minutes. And then certainly I want to be sure we left some time at the end for, call it more traditional Q&A. Perhaps there might be questions to the group. But also I think it should be rather interactive. So while people expressing opinions and have thoughts, I personally think if somebody has a comment, raise your hands, and we'll see. Try to be as flexible as we can. And as I said, it's a first attempt. I would suggest as a start, because not everybody from the panel has been on stage here before, I think we do a quick intro, and I think we start with Charles, who is online. Charles, can you introduce yourself?
Yeah, hello. So sorry not to be there in person. Can you hear me? It's okay?
1 second, it was rather loud, but we are fixing this right now. Try again.
Is it okay?
Yeah, it's okay. Very good.
Okay. Let's restart. So sorry not to be there in person. I couldn't travel to Belfast, but so I'm Charles Reeves. I'm working at Stellantis. I'm a tech lead for CFD methods at Stellantis for quite a long time now, and and been talking to Burkhard for quite a few years also, and happy to join to have a talk with all of you.
Thank you, Charles.
Good afternoon, everyone. My name is Karthik. I'm from Jaguar Land Rover Research, and I've been in the business for less than 2 years now. So I'm working on CFD simulations. I don't stick to just particular domain. I work on external aerodynamics. I work on battery thermal management. I work on multi-phase flows. I work on things. So anything that requires CFD where the core department couldn't accommodate will come to me, and that's what I do. It's good to be here. Thank you so much.
Yeah, hi, my name is Ananda, and I am at Volvo Cars at head office in Gothenburg. Mainly working with the transition between concepts to engineering. So I work a lot with the detailed car simulation, full car simulations, wind tunnel correlations on road testing, wind tunnel certification, and things like that. So this was a very, very good for us, I should say, seeing so many different opinions on CFD. I'm a numerical guy basically, so now I'm trying to move a bit into the experimental world. So that's why I'm constantly questioning, is the experiment data still relevant? But yeah, it's a pleasure to be a part of this panel, and please ask me any questions you have.
Yeah. Hi, my name is Vilem. I'm from Skoda. I'm leading the CFD group, the methodology group in the aerodynamics department. we recently not dealing just with aerodynamics, but also with multi-phase, with vehicle thermal model and other application aeroacoustics. And yeah, big thanks to everyone. I think it's like great melting pot of academia in industry and CFD vendors, big or small. And yeah, my colleagues, they said we are customers as an OEM, and for us, it's like really crucial and necessary to have reliable, trustworthy methods we can use for developing cars. So thanks a lot.
Good. I perhaps also mention quickly my background at Ford. So I'm a senior technical leader at Ford, responsible for CFD method development across many attributes, thermal analysis, aeroacoustic, water management, brake cooling. But then spend most of my time in aerodynamics, and that's obviously what creates the interest in this workshop. And so I think what we would do next, I would ask all the panel members perhaps to reflect a bit on what they have seen and heard over the last 1.5 days, and perhaps aspects they want to emphasize and mention, and then perhaps we go a little bit into a few individual topics. Yeah. Well, no, Charles, if we want to start with you again, any observations you want to share, any things you want to highlight?
Many things, many things. Interesting, and good quality of the presentation. So that was really nice. What pops up to my mind is this morning's about the noise factor group, because actually it's really addressing one of the biggest concern we have with scale resolving simulation. Like, as we are mostly interested in getting small increments, this really shows what we are struggling to get. Is this like having nice time convergence and things like that without running 60 seconds simulation like what we would do in a wind tunnel, average on 60 seconds or 2 minutes. That's really what is our biggest pain today. So that was really interesting to see all these interesting results, even if we don't have all the answers yet how to address that. But to me, that's one of the biggest concerns we have with scale resolving simulation. Many things many outcomes to to get from this meeting. So yeah, at the end of the day, I will have to review the recordings to make up my mind on certain topics, but really appreciate it. I don't know if the other colleagues have want to answer about this like noise factor and time convergence issues, or if I should continue on other topics.
We go around the table first and see what other comments we have, and then we go back to individual topics, I would suggest.
Mm-hmm. For me personally, I think this is one of a kind, because I've been working in academics for a while, and I used to attend ASME, AIAA conferences where certain presentations and workshops will be so related to me, and some are completely deflected to me, so I will not be interested to listen to few presentations where I will be so keen to listen to few. But that's entirely opposite here. Each and every TFG and every presentation is so related to me, and we are constantly working on all of these TFGs and trying to prove or improve it. So this is so good to be here, and especially the AI thing for those honest presentations, giving those data. I should appreciate them. Every TFG in that sense. So this is something which I'm happy that I'm here, and I'll make sure that I'll be here at the end.
Excellent.
Yeah, kind of reflecting on what Karthik was saying there. for me as well, this is the first time I'm at AutoCFD. I've heard a lot about the community. I've been a part of the TFG. And I think what we are building here is really encouraging and positive, both for OEMs, industry, for academia, for everyone. I mean, because we're constantly interacting. We have a common problem that we all want to solve. And I think that is a really good platform to begin with. Some reflections. I would say that the quality of the presentations was really top notch. I mean, I have been to several conferences myself as well, and usually the quality is not consistently high for all the presentations. And I think this definitely is one of those special moments, where everyone has really worked hard. And I mean, that is really appreciated because it's very hard to convey a simple message in 10 minutes. So I think all of you should give yourself a round of applause for an excellent contribution. And I mean, we of course thank the organizers as well because of how the whole thing has been structured, giving us, we're not meeting each other for the first time. I mean, we have seen each other in different fora, spaces out there. And that kind of brings a bit of familiarity when you're in the room, and then you're not that hesitant to go and approach a person, So it creates this more of a friendly vibe, which is really encouraging, especially in events like this. Now to get to a bit of a criticism. I wouldn't call it a criticism, but it's mainly yes, we are all trying to solve the same problem, but at least my observation here is that we are trying to match CP as an example, yeah, but then we are missing CD. And as automotive industries, that's where our bread and butter is. We are really fighting for every half a count or every 1 count. And if our methods have a sensitivity of 3 count CD, that is a bit of a problem. And the noise factors group, I mean, I don't want to overstate this, but then I think that is extremely relevant for us. And also the scale solving simulations, I mean, that's also where we know that, I mean, we looked at a lot of the results, and I was like close. I actually wrote down what each one of you have, reached your CDS. So it's kind of my little report card to see who actually made the 255, which the driver with the front wheel deflector had. And it was not many, let's say, results that actually matched that. And for me, that was, I wouldn't call it concerning, but it was like, okay, why have we not reached that? Is that not really important? Are we so obsessed about meeting CP and capturing all the turbulent structures that we're kind of missing the whole picture here? I mean, that's just my reflection. And on the AI, I think that's very encouraging. And we at Volvo are also looking at this quite a lot, and we're very thankful to Neil and his team for creating such an amazing data set. It's not easy to find data of this magnitude and quality for training internal models and making it available for even commercial purposes. That's again, great work. I think I shouldn't talk more. I should let the rest of the panel speak as well. But
yeah, I also would like to thank to everyone. It's not just yesterday and today's sessions, but there's like 1.5 years of preparation. So big thanks also to organizers of this workshop. Also, thanks to Neil for preparing 500 cases for drivers with colleagues, and of course for preparing simulations, processing them, presenting them. I can't wait to get back home to Czech Republic, to open the dashboard, open the presentations when they're going to be uploaded and shared, to really search, because I think there's also a lot of information which we couldn't share or express in 10-15 minutes. They're like, it's a little bit hidden, so we need to a little bit take time and analyze it. But what I've seen, there's definitely something we can continue to work on. We did, even though at the beginning it looked that we didn't improve so much, there's still that spread of 50 drug counts. There are many areas we improved, and for example, 2-3 years ago, if you tell someone what is noise factor, then probably me included would say, oh, I don't know. Now we know it's serious, we need to take care of it, and we have some first informations, and we can continue working on it. So I see that added value. We definitely are going to join next year or next workshop. And yeah, big thanks from Skoda side.
Very good. Yeah, if I can add a few comments, and I talked to some of you throughout the last 1.5 days, and I repeat comments which I made in these conversations. I'm with AutoCFD now from the first workshop which Neil and Gary organized. But I think generally speaking, if I look back to what happened throughout these last workshops, but then not only through the workshops, but think about what I see happening in the last 10 years in aerodynamic CIE, I would say I would describe it as stagnation. I think 10 years ago, we started to run, perhaps even a little bit more, but we run transient analysis using hybrid turbulence models, PDS, Palma-Damaros, Comic SSD, and we ran this on a large number of CPUs. Turbulence model have been gradually refined. CIE processors have gradually improved. CPU speeds have gradually improved, but not much game changing, to be honest, in the last year. So I really got a bit frustrated with the situation, because on the other side we see there's so much demand in getting more accurate, getting faster, that we could not be satisfied. And I think I'm coming back from this workshop with the strong feeling that we are moving. So there was a lot of attractive things we heard about: fast computing, GPU computing, which seems to be a big enabler in this space. We heard new ideas about turbulence modeling. We have seen how perhaps GPU computing enables LES applications, so that was interesting to hear. We hear that AI gets traction. So I think that's just good news in my mind. We are still, there's more work needed until we can actively make use of this, but in that sense, a very positive discussion and a very positive outcome of the workshop. So that's the key impression I'm left with after this, and that's very good. Perhaps we quickly pause here just to see, does perhaps somebody wants to add a comment on a general level? He wants to share something we have not mentioned so far, or a question regarding what has been said? Okay, if not, then what I would suggest, perhaps we heard already a couple of comments regarding this, but perhaps we still spend a minute a bit to go a little bit deeper on this noise factor stuff. I think like everybody here mentioned it, how it's relevant, and let's see whether we have a few more comments beyond what has already been said to this topic. I think it's, if I make a start at sort of turning the order once around, it's something where it can easily get you sidetracked. You look at stuff, you work on turbulence modeling, you work on meshing effects, and you try to make decisions how to improve your best practices, and you don't recognize that at the same time you're running jobs all the time on different CPUs, and then somebody says, I run it on twice as many because I need more throughput, and you make decisions based on this day to day, and these decisions are by no means mature. It's easily, these noise factors can mislead you. And then I said that, I think, in one of the introductions before, what I see happening, at least on our side, we are making decisions on a day-to-day basis based on CFD. We're driving designs with CFD, and we are confirming in the wind tunnel. And we are making decisions where we are talking about 1-2 drag counts. We might we would not always act on 1-2 drag counts because we would say that's a too expensive design change to justify, which I cannot justify with 1-2 drag counts. But then sometimes there is design changes which perhaps are kind of free of charge, yeah, which is just a surface modification. And we would suggest such a modification because we predict a 2 count drag improvement. And so again, that we need robustness on this level. So it's very, very relevant. I think while we are talking about this, the one thing we always need to keep in front of us is this, let me call it statistical relevance. Yeah. So is the simulation you've done properly stabilized? Is the averaging interval properly chosen? Because otherwise you cannot even start thinking about your noise factors because you just have statistically irrelevant, but questionable results. So I think we have seen a couple of good examples today where people paid a lot of attention applying mean curve or similar concepts, ensure that they have very relevant results. And so that should not be underestimated. And I would like to encourage software developers, researchers, perhaps to look into this. I always remember the discussion I had with Hupertz, was it the last workshop, who was just looking at me and felt he would say, are you crazy? Why the heck should you have any noise? Yeah, it should be all 100% repeatable and predictive. Yeah, and it's not. Not in our world. Yeah, it's we have all these noise, and it's real. Yeah, so I think you see how important this to the OEMs, and perhaps if you want to keep this in mind.
Yeah, I would add it's a really hot topic. So probably you've seen that we spent 300 simulations on that, and it's just a tip of an iceberg because we couldn't show in 15 minutes everything. It's very relevant for us. It's Burkhard mentioned that you can be misleaded if you have that noise in your predictions. When you prepare best practice, it's not just on like when you are working on the car like a project engineer, but when you are CFD developer and you try to find the best CFD setup, then it's if your results are with the noise and uncertainty of free drag counts, and you are trying to improve your method to be able to capture 2 free drag counts delta, then it's impossible to fine-tune your code. You'll spend a lot of time coming back, iterate, try, impossible to improve, and then you realize, okay, it's just because of the noise in my simulation. So for us, a couple of years back, it was like wake-up call when we realized this, because run simulations, they are in this aspect like stable. You can get better repeatability on different hardware, but with transient simulations, it's a problem. And in the last years, there was significant improvement on HPC, also on the software side. So 5 years ago, we were happy that we are able to compute 1-2 seconds long simulations. It took hundreds of hours on cluster. And then, of course, you can't even think in that situation that you would run 60 seconds long simulation. But as computational power is more and more available to us, then we started to ask those questions. And how does it look if I run simulation for 60 seconds? Is it similar to behavior we observe in wind tunnel? And yeah, so it's all together now. It seems it's the right time to deal with it. And I think, I already mentioned I think all of us did huge improvement on this topic. I believe we again next workshop can present maybe more answers and maybe even wrap it up somehow.
Good. Yeah, and for me, I mean, the methods that I developed at Volvo and that we use internally, it's pretty much the same things. I mean, we have taken it for granted that we are going to have an absolute error of around 3 to 5 counts. I mean, that we take. But then it's fine as long as we get the qualitative predictions in line. And sometimes that is also slightly off if we have, the wrong statistical averaging done on the signal. And for us, at least, this is the wake-up call that they had. This is our wake-up call, and we have been. I'm not saying we've not been looking into it, but we can now look into it more, mainly because of the computational resources and and how efficient all the solvers are getting. And now I think GPU is definitely the game changer here. And when you look at the insane performance figures that some of the new startups are quoting, I mean, that is really game changing. And that affords us to run 60 seconds, maybe even 120 seconds of a complete wind tunnel simulation. And those are really computationally expensive simulations. And we can do that because of the hardware, because of the capability now, which we couldn't do maybe 5 years ago. So this is a really good time, for us as OEMs, that we can actually have a little bit of a reality check and go back and fix. Because we're already there. I mean, I'm not saying we're far away. We're almost there. It's just what we're doing now is for the last few counts, and that's always the case. We are fighting for 2-3 counts. So we would like to have the accuracy that which is possible. I mean, it's not impossible. So it's only a matter of time, is what I believe. And hopefully by the next AutoCFD workshop, we will have a solution to this. Maybe there are even more faster GPUs and you can start simulating stuff on your phone. I mean, I don't think that's too far away from reality. But yeah, it's a very promising time to be in the industry right now because we are at the forefront. And maybe I will take one, I will just stop here, and I would also like to comment a bit about, I had this very interesting discussion with some people here in the audience, and it was mainly comparing life in F1 against life in an OEM. And you're always thinking, okay, F1, they're going to be having state-of-the-art in everything. Yeah, probably not. I think we in OEMs, we're doing more. We invest a lot on development, and because for us, each of those counts, they really matter. And if we can reduce one wind tunnel test by running, let's say, 10 simulations, that's a huge saving. And companies are pushing for it. These days, there's a really strong push from most companies, I think. They want to go into the digital world. You're hearing digital twin everywhere. I think Siemens mentioned digital twin. That is the future. So if we need a digital twin, then the twin needs to really represent what we see in reality. And I think we're getting closer to that.
Burkhard, there's a couple of questions, but I don't know if you want to.
Perhaps we let this round complete
Just
and then we'll, yeah, absolutely.
Okay, in that case, I'll make it quick. Yes, I strongly believe noise is something which has been there for decades, but we started to have a more concentrated look recently, and one good thing that made us look is the computational ability that we have. Like a few decades before, if I go and say to someone that I want to run 300 different runs with 6 million mesh elements, they would say, no, you are crazy to do it. But now 6 million, 300 runs is nothing. You can do it. So the better the computational facility, it has helped the noise factors and to understand the noise factors, I would say. So all thanks to computational facility, I would say.
Charles, something to add from your side?
Yeah, just one general comment about let's say the whole community from us OEM. I started my professional life at a time where simulation was a commodity. It was coming on top of tests. We always had the test to compare if needed. Now I don't know for other OEMs, but I'm pretty sure it's going the same way. As a colleague said, everybody wants to be to digitalize. That means we now need simulations to be reliable, and we can do errors with our simulation that actually will bring more issues than in the past, because now we rely directly on the simulations. And that's actually our top management, all of us, I think, really think that we can do everything with simulation, and that's why we really need this kind of workshop to continue to push to push simulations in further and be more and more reliable and be able to replace test. Because it was, I lived in a time when I had to prove I could replace test with a simulation. Now, anyway, we get rid of the test, so you have to deal and do it with simulation. So I think the game changed in the past years, and we really need to get further, and not only thinking about the nice and beautiful CFD with very nice and beautiful turbulence models, a perfect turbulence model that will never happen at the end of the day. But take into account all of this, all of what comes into the process, the meshing, simulation time, noise factors, turbulence modeling that still have to improve. So I really think the way we went with this workshop, the way we organized is a good, the good path, and I hope we will follow it. And one last remark: compared to other conferences, you have the fact that we organize now in let's say at least 1 year to talk together to prepare these workshops. It's not a conference; it's a workshop, and that's something that is more teamwork. And I think it's really, it really brings something very good for the community.
Very good. Let me make one summarizing comment here, because we keep talking about noise factors, and you might say perhaps, should that be the dominant topic? We have other things, but what it means to me is that let's say it's an expression of how serious all the companies are about using these factors. If noise factors start to matter to us, then it's because we need to rely on it. So I think the digital twin is a given reality. It's not that we are waiting for it to come. We are making decisions nowadays based on CI every day. Perhaps in aerodynamics, you might have already early on the ability to test. You mentioned thermal management, others. You don't have this ability, so you rely on CI and you're making decisions based on CI. And we do the same in aerodynamics. So the noise factors is just a kind of, let's say, it's an expression how serious and how important this is. Here, you had questions.
Oh yeah, can you just repeat? The question was, how important is accuracy relative to directional change? So I think trends rather than just pure accuracy, and also the ability to fit into a standard process that does not need to adapt to new geometries. I'm not sure what the second bit means, but maybe you could comment on the accuracy versus the direction.
Perhaps let me start with a comment, and I'm sure there's more comments. I would say directional accuracy is for me kind of the highest priority. Again, if I could get absolute accuracy, I'll obviously take it. But I think we have to make these design decisions every day to decide whether a certain modification will be positive and should be done. So I think that's in my mind most critical. I think the question Ananda has raised, certainly we are not giving up on our goal to also achieve absolute prediction accuracy, but that might be a longer way to go, as we also have seen from the workshop. But I think certainly the other thing, my interpretation of the question is, I guess it's correct to say that all the OEMs have absolutely clearly defined best practices. So it means that I don't think anybody here would start thinking about how to set up a model, how to mesh it for every new geometry in a new way. We have a defined standard, use that standard across the board. There might be exceptional cases where you recognize all of a sudden there's something special, and then you might modify your best practice slightly, but generally speaking, we have to go with best practices, otherwise we go nowhere. That's my perspective.
I mean, I agree with what Burkhard just said. Yes, absolute accuracy is the holy grail. I mean, we can take time to get there, but let's say delta changes and directional accuracy is more relevant on a day-to-day basis, because you are constantly working with different stakeholders and trying to give them feedback, and the feedback that you give should be, let's say, reliable. At the same time, we're talking about, and this is something that I want to raise myself, and this is about accuracy to, let's say, speed, because that game is also really important. We can have really accurate simulation results that take, let's say, 92 hours to 90 plus hours to run, or we can get a quick result, which is not that accurate, but then we get an answer in 12 hours. So this balance is also quite important, and that's something to keep in mind. Certain questions need very accurate answers, while certain other questions don't really need that. So there needs to be a balance here. So both the factors are important, but I would say that directional change is I think the more critical one, at least right now.
Yeah, maybe I can add maybe a little bit different perspective, because at Skoda we don't have our own wind tunnel, and we rely mostly on CFD for a long time, since like we started with CFD simulations. It doesn't mean that we don't go to wind tunnel. We go to Germany and we measure, but that ratio between like industry standard is maybe a little bit higher on our side, because it's quite difficult to drive there 6 hours, measure and go back, and it's quite expensive. So I agree that trends are currently more important, but it's a couple of years back, there's a trend to reduce number of physical, like hardware model tests. And we are already in a situation that for some projects, we don't have any wind tunnel models. So we can't go to wind tunnel to measure, and we completely rely on CFD predictions. And then absolute agreement, absolute values are getting on importance. So probably in future, those cases where we can't go to wind tunnel will be more often, and then we really need to take care of absolute agreement as well. This I wanted to add experience from Skoda.
There's another question about so the bulk of the results presented in these 2 days are wall function. And when we're talking about a couple of drag cards, wall function versus wall resolve then is truly in the game. Now, what's your thoughts there?
Speed against accuracy. I don't that, unfortunately. I mean, because we cannot wait for, in some cases, 48 hours to give a decision, right? I mean, we want it to be done. I mean, the dream of, let's say, any engineer is to have an overnight simulation. I think that's all what we're working towards. So if we are able to get the answer faster, then we have more time to kind of process it before we give it out. Because what sometimes happens is the simulation takes a long time, and then you are in a kind of a stressful situation to process it and forward it. So you're not afforded the time to actually distill all the information before it can be given, and that's just purely just the stress. I mean, you also relate to this. I mean, not all projects are running really long. You have like strict deadlines, and you need to give changes, and you need to give feedback at very strict points. So
it's just an interesting contrast with the aerospace industry, which is historically Y plus a quarter or a half,
yeah.
Particularly with transition models. We did the test, by the way, in AutoCFD4, we did the Y plus 1 mesh, the predictive versus wall function, almost all of the variables are identical. But that juncture, I think that's what proves it.
I think what comment I would add, to be honest, so far there was no reason for us to think about this, because it was kind of not really practical. But it looks like we're getting there, and so I think perhaps you ask the question again in a year's time or 2 years' time. I hope that we would have more experience. Again, still what Ananda said matters a lot in this, but yeah, we'll see. There might be opportunities.
For me, I would add that sometimes it depends on implementation in CFD code. Neil and Burkhard mentioned that last workshop we compare it, but from our experience, because we used to CFD softwares, different softwares, we can see some differences between them, how they implemented all functions. And in some software, it's almost identical. In other software, there's like better prediction with low Y plus meshes. So it depends on situation, on application, but this might be.
Okay, I think as always, time is running faster.
There was one more.
Okay.
I think it's quite a good question. It was saying that given that drag is predicted reasonably well, I think, in terms of a few accounts, where beyond drag prediction is the next frontier of CFD in automotive. As in, what other quantities are important? I guess he's meaning maybe thermal or acoustics or stuff like that.
I mean, I would like to take this question if it's okay. Yeah. I mean, we talk a lot about drag, but we're missing another important aspect, and that's lift. And I think lift is equally, if not more important. And that's something we struggle quite a bit. I don't know how it is for you guys, but I mean, we are trying to predict lift using CFD in many cases because it's quite relevant to balance it with other stakeholders, since we are relying on other people as well on these results, because drag is typically consumed by a few, but lift is reaching out a bit more. And so drag and lift are quite important. And at least my guess, from a purely aerodynamic perspective, is that these two are the main frontiers that we need to find a solution for. But if it's the other aspects you're asking about, thermal comfort, yeah, sure. And then maybe Karthik or you guys can answer this.
Applications like soiling.
Soiling, contamination, yeah.
Water management, a bit of bedding, everything matters.
Yeah.
Charles, do you have a thought you want to share?
Yeah, actually, not exactly this. I agree with what was said, but yeah, thermal stuff and so on. But yeah, I don't know if the workshop should go in addressing all the CFD test case that we are encountering, and we still have some Pandora's box to open. I know we decided not to talk too much about that, but there's wheels. This is one of the Pandora's box if you want to talk about aerodynamics. And I think for lift, this is also a key way to go to lift, because I've never seen a simulation that was robust on lift. Sometimes you have a lucky shot and you get the lift. Okay. And then you look at the front lift, the rear lift, the error compensates and somehow you get it. And that also needs a lot of comprehension of how it's measured in the wind tunnels, because wind tunnels there's a bit of tuning on this matter, but that's a big key point to move forward to digitalization, because lift is something that is still very complicated to get.
If I can add one more comment. We recently can see some trends shifting also focus towards like on-road conditions, maneuvers, and this will bring a lot of challenges for us to simulate, not just compared to wind tunnel, but like real conditions on the road.
Perhaps one thought, and again, I'm well aware that it goes kind of beyond the AutoCFD scope, but I would say specifically in the world of battery electric vehicles, I'd say the reason why we do aerodynamics to a good extent is because of energy management, energy efficiency. So it's all about battery cost and battery range. And so this entire context which is needed to deliver energy efficient vehicles. So it's the pure dynamics on the one side, but then you mentioned human comfort, cabin being a big consumer of energy. That requires typically extremely complex models. Full CHD models, which include the exterior airflow, which include the cabin, which includes the entire solid structure as a thermal mass. And then ideally you have a good validated human comfort model, which is a problem in itself. I think that's, to me, that's the carrot. And aerodynamic has to play its role. And And I think that's where we're focusing on here in the workshop. But it's the bigger picture thing in my mind is the energy management.
If I may add something, in the workshop or in many conferences or looking at driver or simulations and mockups, there's something that rises up when you work as an OEM, is that actually in our simulations we assess that the car is rigid, fully rigid, nothing moves. So the belly panels are rigid, the Adams are rigid, and so on, and that's on our side. That's something we are starting to trying to assess, because you go to a mockup, you have an assessment on a mockup, you got the first, let's say, prototypes, and there are some stiffness issues that once you come to, let's say, the final homologation, you have sometimes bad surprises because stiffness makes some parts move. So I would say also FSI in the future is something also that we will have to take into account. Of course, mockups are quite rigid, but actual cars, there are some plastic parts that actually deforms, and that can affect the CD, CL. So that's also something to address in my mind.
Very good. Now, as I said before, we have certainly been too ambitious with the topics we listed. John, quick question. I don't think it makes sense to start discussing any of the other topics. We only have 5 minutes to go. I would rather see, is there still a question from the audience which we can try to answer?
I've got a question. I wanted to know your thoughts on crosswind, yaw. Everything that we're looking at is at 0, and at any speed, the real yaw is non-zero. So I know that's a big thing, but let me just give you a scenario, and I want to get your opinion on it. Let's say you do CFD on a wheel deflector, and it's better. Option A is better than option B at every yaw angle but 0. Which one do you choose?
That's a very interesting question, actually. And I think one of the mistakes, that I wouldn't call it a mistake, but we are typically designing our cars for 0 yaw. That's the reality. We would like to include all kinds of, let's say, stability side forces and, stability, basically. And I mean, if you say that a wheel deflector is worse at all conditions than at 0, then we would still not use it because we have not seen the performance at 0. Why? Because when we certify the cars, we don't certify them at yaw. When we are doing range tests in the US, not done at 0. It's not done at yaw. We are driving on a straight track. A coast down, if you think of a typical coast down, right? It's on a straight track. Maybe have a slight curvature, but most of the relevant forces are being measured on the straight line. And when we are talking about range targets and all the regulations and what Burkhard spoke about, the energy efficiency, all our products have to live up to a certain benchmark. And if we have to reach that, we have to design the car to be most efficient at that benchmark or that state. Everything else is, I would say, secondary. Although that's probably does not answer your question entirely, but at least you see how we are thinking.
I think is it perhaps also fair. I'm not aerodynamicist. I'm the CFD guy, but I think what I certainly have seen, if you would have designed this feature, yeah, and you would have recognized that it shows a tremendous yaw sensitivity, you would perhaps not go for it.
Yeah,
because,
you will reiterate and go back to the design.
Yeah, you want it to be yaw insensitive to some extent. Again, it will not be fully yaw insensitive, but you would be very concerned. That could be a very unstable scenario you're looking at.
And you will get complaints directly when right-hand take the car. You will get the complaint directly. It doesn't work.
Yeah, as Anand said, it's like the goal is that certification process and it's straight. But I think we all will agree that we take care of our customer experience as well. So I can't recall any situation that would, as you described, happen that we need to decide between 2 cases. We would go back to our drawing boards and then redesign the deflector, make it less sensitive.
Yes.
And yeah, but
Perhaps to build on that question a bit, a question which has been asked before, which I think has relevance, is this question that we have to ask ourselves, what happens in a real wind scenario with gust? Would be an optimization of a certain design still be valid under this condition? We have in the wind tunnel as well as in CFD, we obviously have very limited turbulence in the flow, and there have been examples where answers were different under gust conditions compared to low turbulence conditions. So that kind of relates to what you're talking about. Any other questions before? Good. No, looks like we are able to finish this on time. So thank you very much for supporting the panel. And